What is up, guys? Welcome to the Triage Method podcast. This week, it's just myself, so Paddy's not joining us. He'll be back on for the Q&A episode, but I'm joined instead by the nutritional Ziz, or nutritional advocate, Mr. Alan Flanagan, lawyer turned scientist, and we're going to be discussing the topic of the temporal nature of nutrition, you could say, or chrononutrition. Okay, so basically, meal timing, all the bros have been telling me back in the day that meal timing was everything. All the evidence-based bros were telling me that meal timing doesn't matter at all and it's totally irrelevant and just hit your calories, bro. And Alan is here to kind of be the guiding light and point us in the right direction. But before we get there, Alan, what's the story with you? Who are you? Where did you come from? You came into this whole nutrition thing out of a very different field with some crossovers, I guess. So give us your background.
So my background, I meandered into nutrition. So as you said, lawyer turned scientist. I started with a humanities degree in history and English, then did law in Dublin in the King's Inns, got called to the bar in October 2009, or started deviling then, spent 9 years practicing as a barrister and really enjoyed it, but also had that kind of inkling of wanting to have other options. And I had a huge academic interest in nutrition. I like a lot of people, I got interested in more so kind of from my involvement in sport, and then naturally gravitated to reading research to try and kind of pick things apart that I was reading on the internet, and then realized that I didn't have a clue what I was doing reading research. So I started a more formal education route, found my way to an MSc at the University of Surrey, which was modular and had a kind of unofficial couple of places every year that they kept for people from non-traditional backgrounds. And I kind of got in on that basis that I was a lawyer. I was interested in kind of policy and regulation stuff, still am. And originally was doing this to kind of have an academic interest and not necessarily seeing where it would go, but being open to where it would go. But over the course of the MSc, just kind of continually more fell in love with the research side of things. And when I finished that, then got offered a PhD that was full-time at the same university. And that was the fork in the road. So there was no way I was going to be able to do it part-time. It was in this area of chrononutrition. It was a human study and human research, which is not often what people get to do in PhDs for various reasons. And I jumped at it, and that was it. I took that fork in the road, and I'm now a former lawyer and current scientist.
Nice. You're also a powerlifter, I believe. Just
yes.
For the bros, you got to get that validation.
Yeah, exactly. I lift things.
And that's the most important thing, here.
That's it, exactly.
The
that's my authority bias right there.
And why the PhD area that you happen to get into? Why chrononutrition?
So, I was really interested in, historically, not even still currently, I've just always been a bad sleeper. And I became quite interested in reading sleep research as a way of trying to improve sleep. I got very interested in trying to improve my own sleep hygiene. And in the course of delving into that area, it came across this concept of circadian rhythms, which we'll explain. And how we are kind of intrinsically built for certain patterns of behavior. And I was like, this is really interesting. This is fascinating. And as I dug into that, realized that there was an emerging nutrition component within that science. So my MSc research was in night shift workers, NHS workers, where we were looking at the change in how much energy they consumed from one shift to another and how they kind of redistributed their energy. And I just got quite interested in this idea of, because nutrition science is a fascinating area of research. Generally speaking, we're focused on the nutrition component to it. But what I was finding was that this was kind of superimposing nutrition or overlaying nutrition on this really important underlying physiology that we have. And if the two of them are disconnected, then that's potentially a factor that explains a lot of potential risk for chronic lifestyle disease like diabetes and cardiovascular disease over the long term. So sure, what you eat is important, but the when you eat component might be particularly important. And it seems to be very relevant now for the way that we live kind of modern lifestyles, where we often have enforced wake times because of a commute we need to do or work. We may not necessarily enjoy that. We may be a kind of what they call a night owl. We may prefer to kind of stay up later in the evening, feel that we're maybe more productive and awake in the evening. Some people do. And there are all these additional factors that go into it, that it's not just as simple as, well, eat breakfast first thing in the morning, or, have X amount of food at any given time, really. So there are a lot of moving parts to this, but ultimately the one thing that isn't a moving part is our physiology. Yeah. So actually, we've been talking all the time in nutrition about just these general nutrition principles. There's only so far that you can superimpose that onto kind of biological factors that are essentially set in stone for us as a result of our evolution. And there's only so far that you can bend those principles before they break. And night shift work is probably the best example of that, because independent of any other factors, consuming food during the biological night is a major issue, amongst other issues like lack of sleep and stuff like that predisposes people to diabetes and cardiovascular disease. And so while historically a lot of focus has been on night shift work, now we're starting to realize that actually even within our daily temporal eating patterns, like, these are relevant factors that add up. So I found it quite a novel area of nutrition, a new enough area where there's still a lot of stones yet to unturned. And I thought that was really attractive as an area to maybe try and get into, and see where it goes.
Yeah. So with that in mind, chrononutrition, as you said, is basically superimposed on top of the kind of field of chronobiology in general. So what are some of the basic kind of introductory principles that people should be aware of when they're thinking about this term circadian rhythms and entrainment and things like that? What are some of the basics that we should know?
So I think that the basic is, well, a circadian rhythm. So the term circadian is a Latin derivative that essentially means around the day. And what that is describing is we have these internal rhythms in biological processes. So for example, we have rhythms in our glucose tolerance, or how sensitive our insulin response will be to food intake. We have rhythms in our circulating free fatty acids, our energy availability. And when I say rhythms, I mean, we'll have periods in the day where there's a peak in their activity, and we'll have periods in the day where they're lower, and they'll typically fluctuate over a 24-hour period. So that's why they're circadian rhythms. So around the day essentially means that they're around, give or take, 24 hours in period length of their peaking and dropping and all of that. And so these rhythms, in effect, because they're in humans, they're slightly longer than 24 hours. If I was to stick you in a dark cave with no external inputs, after a few days, those rhythms would run at about 24 and a half hours, give or take. Because they're slightly longer than the 24-hour day, but because the 24-hour day is exactly 24 hours, we need external inputs to synchronize our rhythms to the exact time of the 24-hour day. And in humans, the primary input is light. So light is the most powerful signal that entrains us to the daytime. And what makes humans different to mice, for example, or rodents or owls, is the daytime is our active phase. It's our waking phase. It's our period of food, foraging in an evolution sense, or food availability now and food intake. Whereas rodents and owls are the opposite. They're nocturnal. So their biological day is the dark period. Most species are day active on the planet. And that includes us. And so light for us is a very important signal that synchronizes those internal rhythms to the actual external time of day, the clock time of day, we'd call it. And it's how your body starts to anticipate the timing. So it's why, people often anecdotally will say, well, if you've got to wake up for a flight at 5 o'clock, even though you've set your alarm, you find you wake up anyway. We have the ability to anticipate changes in our environment that accord with a certain behavior. So when we talk about entrainment, we're talking about the fact that we're now aligned to that time of day. So the best example that I think is most relatable for people is jet lag. So you fly from here to LA and you've been on an 11-hour flight, you've crossed a lot of time zones and you've gone west. So it's essentially like staying up quite late. If you were to stay in Ireland, it's like you've been at a wedding and you've stayed up till 6 a.m. and you've eventually hit the hay. Like that kind of delay or that kind of extended wakefulness is what traveling westward would be like. So when you get to LA, for example, it may be 8 o'clock in the morning, LA time, but it's 3 o'clock in the afternoon in Irish time. And so your internal physiology is still timed to that Irish time. And it will take 3, 4, 5 days for your internal rhythms to catch up with LA time. And that's why there's always an adjustment period with jet lag. So our rhythms are tied to the external time of day, and that allows our internal physiology to anticipate when we wake up. It allows us to anticipate meal times. It allows our internal physiology to coordinate the appropriate response in terms of insulin secretion, glucose tolerance, glucose uptake, or energy expenditure, all of these things. And so it's critical because those internal rhythms that we have, and this is something we touched on just before we started recording, but this is so important because the idea is, while that your nutrition is adaptable, for example, or other behaviors are adaptable, you don't have to, for example, train at 8 a.m. You could train it whenever you wanted really during the day. But these internal rhythms are going to run according to a roughly 24-hour period, independent of any other inputs. So your melatonin is going to elevate generally at a time that in humans would be the biological night. Melatonin is a really important hormone that signifies like sleep onset, and for circadian entrainment is important. Your glucose tolerance, for example, independent of when you eat, is going to be amplified and more optimal in the early part of the day, even if you were in that pitch black cave we described with no other inputs. So the functions of those rhythms are going to run independent of other factors. And they're optimized when we synchronize those external factors, like our light exposure and our meal timing, to the timing of those internal rhythms. And when we disconnect the timing of our external factors, external inputs, from our internal rhythms, then we are in a state of what's known as misalignment or desynchrony. And that's what we see with shift work. It's what we see with jet lag. But what we're interested in now, because people generally, when we talk about this field, will say, well, yeah, but jet lag's extreme. You only maybe experience jet lag maybe twice a year, or I don't work shifts. This stuff isn't relevant to me. But what we're starting to see now is a term known as social jet lag. Mm-hmm. And that's the disconnect that people have in their everyday life from their sleep-wake timing differing from their work days to their free days, or their disconnect because their internal kind of preferences are more for evening And we do have differences, genetic differences between like morning types and evening types. So if you're an evening type in modern society, and we have early school start times, early work start times, you're more predisposed to disconnect between your internal physiology and the external clock time. So these things are relevant for day-to-day life, and they're highly relevant then for nutritional determinants of chronic lifestyle disease.
So we've got this kind of background circadian rhythm, which is
Yeah.
essentially endogenous. So that exists basically independent of any other stimuli. Then when we build on top of that, we've got those kind of those factors that entrain, whether it be light or food, etc. So could you give us an insight into what the difference is between, let's say, between like the regulation of the central clock and the peripheral clocks rather? Because I think that's quite insightful in terms of differing between light and food, and then moving on to the nutrition side of things.
So there are two kind of clocks, like you mentioned, that are broadly talked about in circadian humans, and in a lot of organisms. Light is the primary driver, the primary signal of entrainment. And that's because light is picked up on by our eyes. We have really specialized cells in the retina that communicate directly to a specific gland in the hypothalamus, and they communicate only information about light. It's this really elegant biological architecture. We have this dedicated pathway from our eyes to this specialized area of the brain, which communicates information about light, and then that information is kind of coded in this area and processed in this area that we call the central clock, or the master clock, and that's in the brain. And so the master clock is required for circadian synchrony throughout the body, and the master clock will communicate downstream to the rest of the body to synchronize everything to this external clock time. But what we started to realize in circadian biology, and this does go back like 30, 40 years, maybe even more, is that clocks in peripheral tissues, your heart, pancreas, kidneys, lungs, skeletal muscle tissue, adipose tissue, clocks in all of these tissues, that obviously, and our gastrointestinal system, the circadian clocks in each of these tissues are all autonomous of the master clock as well. So they get input from the master clock, but they're not entirely dependent on it. And what this allows us for is a degree of flexibility in biological timekeeping. So the best way to characterize the difference is, the central clock is kind of calibrated for precision, and the peripheral clocks are also calibrated for flexibility. So we have precision in our timekeeping, biological timekeeping, but we also have flexibility. And that makes sense from a biological or from an evolutionary perspective, because the light and dark cycle is relatively constant. So even though we might be in an area of the world like we are, for example, in Ireland or the UK, where from the winter to the summer, there are differing period lengths in how much of the day is dark and how much is light, we can adapt to that. That is always going to be within a 24-hour period. There is going to be a light and dark cycle, and it's going to be fixed in its timing. So if it's in the winter, it's going to be fixed for a shorter light period, and in the summer, it's going to be fixed for a longer light period. We can adapt to that. But food availability may not necessarily, in an evolutionary context, always have been constant at the same time every day. So our peripheral clocks have a degree of flexibility where they can shift, they can move to a different internal timing relative to the timing of food intake. And this is really important because from a nutrition standpoint, it means that we have the capacity to change the timing of rhythms in our peripheral tissues, which are really important for metabolic health, without changing the central clock, without altering the central clock. So this is, again, important to grasp in the context of now talking about how beyond just jet lag, beyond shift work, beyond the extreme circumstances we've typically looked at the nutrition component through the lens of, actually, we have the potential to be influencing our metabolic health and the health of our important metabolic organs and tissues by our meal timing that can be independent of the central clock. So what really the circadian system is going to function most kind of optimally on is when there is an alignment between the signals that both the central and peripheral clocks are getting. So when the light exposure that the central clock is getting is constant and is consistent in terms of light dark, and when the meal timing that our peripheral clocks are getting comes at a time which is coherent with the central clock, then there's this bidirectional feedback between our central and peripheral clocks, and everything synchronizes up, and we're in circadian alignment, and that we think is a more optimal state for human physiology to be in over the long term. And the relevance of this is that, and we'll get into this more, is that you will see differences in people's metabolic response to food intake over the course of the day that's independent from being disconnected or shifting their central clock. So people can still be on the same light dark cycle, but can have a degree of impaired glucose tolerance, for example, in response to meals, or impaired postprandial lipemia or postprandial fatty acid and triglyceride circulation. And these are the factors that we think are probably going to increase risk over the long term. And everything we're talking about here is a potential effect over the long term, obviously. But it's an important distinction between central and peripheral clocks. The peripheral clocks are flexible. They can entrain or be shifted in their timing in response to differing meal timing. And it's one reason why irregular meal patterns or inconsistent meal patterns or later distribution of energy may be factors that add up to predispose someone to cardiometabolic disease over the long term.
Nice. And if we think about that kind of the nutritional component of that, you said, the later distribution of energy or distribution of energy throughout the day, are there variations in terms of like these like if you use the term like Zeitgebers is one of the terms that's used to kind of set the clock. Is there a difference between say different macronutrient compositions, protein versus carbohydrate versus fat, or other non-nutritive things like caffeine, or do these different things affect the peripheral clocks differently?
So the first thing is that caffeine is actually quite a powerful Zeitgeber or time cue for the circadian system, and caffeine will have an effect on melatonin. Caffeine will also kind of phase advance clocks. So caffeine is something that physiologically would be good for jet lag. Caffeine is really good for jet lag as a kind of quote chronotherapeutic. So generally, again, caffeine in the early part of the day for multiple reasons is probably better. And then caffeine has obviously effects that are unrelated to circadian biology, but are still really important for why we don't want to necessarily be having a high caffeine intake in the evening, adenosine inhibition and the stimulation effects and stuff like that. The macronutrient aspect is probably a little bit too early to call in terms of individual specific effects of a proteins versus carbohydrates versus fats. Most of the research is still largely in animal models. So we're generally focused on just food intake per se right now and the effects of mixed meals. We're not really at a level yet where individual macronutrient based recommendations could be made, and it's probably not necessarily that relevant because food intake per se, irrespective of macronutrients, requires a physiological response, requires digestion, absorption, assimilation. there has been a suggestion that perhaps protein and carbohydrate have more of an impact, because both of them will precipitate glycemic responses and insulin responses and this kind of thing. And and the reason that maybe, man, I'm very using very kind of like unsettled terminology here, but there are a number of animal model studies and one human cell culture study excuse me, that have suggested that insulin is an important signal that entrains cells to the timing of food intake. So that might be one reason why, and obviously dietary fat will have kind of minimal to no impact on insulin secretion. So it may be one reason. This is something that I think is worth keeping an eye on. What we see in animal models is that high fat diets shift peripheral clocks and delay peripheral clocks. And the mechanism may be that in the absence of kind of nice insulin peaks, you're not getting that entering effect of insulin. So that's something that is a kind of a future research directions type thing, that there's something coming. But at the broadest level, there's not really that much we can say about individual macronutrients yet. And the field's not at a place where it's like, oh, well, a high protein breakfast is definitely good for circadian clocks. There was another animal model study that came out last week or the week before about how chocolate for breakfast.
Yeah, so
did you see that? Yeah. So everyone was just like, this is great. This confirms my bias. Like dairy milk on my cornflakes. So but broadly speaking, we're talking just about food intake in a general sense. Macronutrients were not at a place yet in the research, definitely not in human research, where we could say that a certain macronutrient composition of a meal would be more optimal. So we're generally talking and more focused right now about and on energy distribution overall, and energy load across the day is probably a more I think it's a simpler way of grasping this stuff, but I also actually think it's just the level that we're at right now in a general sense. It's probably the most pragmatic way of thinking about it as well.
Yeah, so like right now I can hear the echoes of some of my bros in the background when they're listening to this podcast. They're saying, why are you wasting your time on all this when you could just track your calories? So what I want to do is kind of get some buy-in by trying to bring in some of the nuances to the kind of typical real simplified, right? It's just calories in, calories out. It's just energy in, energy out. People often think of that energy balance equation as being kind of a static, X versus Y, as opposed to like a function of X versus function of Y type of thing, which is probably more helpful. So what I want to ask you is, when we think about circadian shift, and let's say someone is experiencing misalignment for whatever reason, it could be a personal trainer who they work at 5 a.m. Monday, Wednesday, Friday, they fast until 12 on those days, whereas on other days they get up later and they eat differently and blah, blah, blah. So for whatever reason, they've got some misalignment. What kind of evidence do we have in terms of, one, that the effect of that misalignment on maybe energy intake or food choices, for example, differences in appetite and gut hormones, etc., or two, the energy expenditure? Because I think there has been some quite significant outcomes in terms of showing that the breakfast eating in the morning versus not eating breakfast seems to change energy expenditure quite a bit. So basically the question is, how does circadian shifting and the kind of meal timing in general play into this more dynamic understanding of energy balance? So when we're thinking about this concept of nutrition as it relates to circadian shifting or kind of meal timing in general. I know a lot of personal trainers listening to this will be familiar with an understanding of nutrition from the perspective of kind of solely just energy balance, so calories in versus calories out. So I guess my question for you would be, you can still hear me, yeah? I thought you froze there again for a second. So my question for you would be, when we think about the timing of our meals, circadian shifting, etc., how does that play into this energy balance equation in terms of, one, influencing energy intake, whether that be just total energy intake independent of food choices, or maybe favoring certain foods over others. And then the second part of that would be, how does this seem to affect or not affect energy expenditure? Because it seems like breakfast feeding might have some impact on total energy expenditure and non-exercise physical activity, you could say. So what's the story there? Is there a reason to believe that this is relevant?
Yeah, I think it is. I think I like you, I've in various conversations that I've had, the place, I guess, that the most pushback has come from about the relevance of chrononutrition has been from the fitness industry.
Yeah.
And my personal opinion about why that is, if we kind of backtrack 5, 6, 7 years, meal frequency was all the rage, and it was this idea that you could actually stoke your metabolism and consume 6 meals spaced evenly throughout the day. And everyone was just like a clock with like every 2 hours and protein feedings and all of this kind of stuff. And the research started to accumulate that actually didn't matter, that you could compare 6 meals to 2 meals, you could compare 8 meals to 1, whatever, that when energy was matched, there was no difference. But the question scientifically that we have to ask is, well, no difference in what? What was the research question being asked? Those studies were largely focused on energy expenditure in a 24-hour period, right? That meal frequency did not impact on energy expenditure, but that's only meal frequency in relation to one specific outcome. And fat oxidation was generally a kind of an outcome in those papers. So the first thing is that, those research questions are specific to the hypothesis that was tested. It doesn't mean that timing is irrelevant across all other aspects of research. And what we're particularly interested in is the response to meals, your metabolic health, so to speak, in addition to other components that may influence 24-hour energy balance. So in relation to the first kind of aspect of that question, like someone who has perhaps very different timing in their work schedule, and maybe works different time periods. So you're describing someone who's like maybe up really early to start a couple of days a week, and delays, and then, for example, maybe has later start times later in the week. That adds up to what we term social jet lag. So the most basic description of social jet lag is the difference in your sleep timing, your midpoint of sleep. So your midpoint of sleep is something that everyone naturally is going to have a preferred sleep-wake cycle. If you were to stick to that, and you're lucky enough to be able to sleep and wake on your own terms, and let's say your midpoint of sleep was 4 a.m., right? Hypothetically, in this individual, if they've got to get up at 5 a.m., they're waking up pretty much around their midpoint of sleep. So their midpoint of sleep might be 4 a.m. Their natural wake time could be 8, give or take. So if they've got to wake up at 5 or even at 4 at their midpoint of sleep to be in the gym training people at 5 or 5:30, there's a huge discrepancy there in terms of their internal physiology. And then there are days where they don't have to wake up like that, and they probably sleep, and they maybe compensate to a degree with sleep. So maybe they sleep till 9. So what social jet lag is the difference in those sleep timings. And it actually is cumulative, and it adds up over time. And what that essentially means is that there is a degree of kind of desynchrony, internal desynchrony, because not only is their meal timing going to be very different between these 2 days, their light exposure and their sleep-wake cycle is going to be very different between these 2 days. So the relevance of this is that there's going to be a degree of disconnect in between their behavioral cycles and their circadian cycle. Within their behavioral cycle, what we're interested in obviously is the food aspect, the nutritional aspect. And what is potentially really relevant here is, let's say, for example, on their 5 a.m. day, they, bring food with them, and they maybe they have a prepped meal and they eat at 9:30, maybe have lunch at 1 between clients, and then they get home, they finish early and they get home and they eat at, say, 6, and they're hungry and they're also tired because they've had to get up really early and they're at it again the next day. And then on their days off, or their days where they get an extended sleep, now suddenly they're getting up at 9 and they're having their first meal at maybe 12:30 or 1, and they're having their second meal when they might be having their last meal on the previous days, and then they're actually having their last meal before bed at maybe 10. So you've got these really disconnected meal timings, and this comes back to what we talked about a few minutes ago in terms of peripheral clocks are going to shift relative, and they have a degree of flexibility, but there is a limit to the flexibility of these systems, because ultimately they're flexible to adapt to a new schedule, but they're taxed when they're constantly being asked to adapt to a new schedule. And in this scenario, this individual is changing the signal, so to speak, every 2 to 3 days. So internally, it doesn't know what necessarily is going on. And what we would probably see in that circumstance, based on the research that we have, is impaired glucose tolerance, potentially adverse effects on blood lipids, and potentially the increased cost of social jet lag over the long term. So while this individual may stay at the same body fat because they're tracking calories, that's the wrong metric for long-term metabolic health. And the relationship between social jet lag and kind of adverse cardiometabolic outcomes over the long term is quite strong. And so what I try and impress on people when we have these conversations, and this is difficult to do with Sapiens because we're not good at computing long-term risk, right? So is, look, yes, if you're tracking everything and you're maintaining energy balance, or you're in a deficit and you're losing weight, that metric to that individual seems to be the only thing that they kind of place stock on for relevance of other nutritional factors. Whereas what I try and articulate is that, yeah, sure, this may not be something that you externally notice right now, but this could be something that adds up to influence their metabolic health over the long term, assuming that this individual, our hypothetical example here, is not going to track calories in MyFitnessPal until they're 63.
I wouldn't be surprised.
So I think I would hope that's a reasonable assumption. So that's what the interest is the potential kind of influence of that disconnect on their metabolic health, and impaired postprandial glucose responses, impaired postprandial lipid responses, and the influence that they would have over the long term. And so that's why, even in this situation that we're describing, where certain aspects of that person's behavioral cycle are going to be dictated by their work needs, it would be they would be doing themselves a big favor by trying to keep some of these environmental inputs constant, even though there are aspects that they can't control. And that's generally something that I try and say to shift workers, for example, is try and keep certain aspects, particularly the meal timing element, as consistent as possible. Like when they come home after a shift, if they're used to having breakfast on their normal days at like 8 a.m. or 8:30, have that when they get home after a shift, you know, and go to bed, and try and keep a degree of consistency with their meal patterns over the course of the shifts.
Yeah, and this is one of the things I find interesting about the way that people critique nutrition science, because very often what I see people do when they look at it, especially in this area, actually, I've seen some kind of attempted refutations. They'll say things like, oh, but like this is just pointless because you didn't standardize energy intake in the study, or you didn't standardize, why don't the people just track their calories and track their macronutrients or whatever? Whereas, like, I think what's interesting in the real world is more so just like I want to know if people eat certain foods, if they eat at certain times, if they go about certain behaviors. I want to know how that affects how many calories they eat, not whether or
Yes.
not they control their calories, because like that's
Right.
kind of boring, and that's never going to
Right.
affect nutrition
Right.
policy or broad scale.
Yeah.
It's
Yeah.
simply, can you be
Yeah.
disciplined enough to engage in the behavior
Yeah.
every day? Like, that's not
And
interesting.
right. And that's to your kind of second point or question, which I think is really important, is it's all well and good to do a 8 or 12-week study with a certain response, particularly the meal frequency literature, for example, that said, oh, meal timing is something we don't need to think about. It's like, again, that was asking a specific research question in relation to a specific outcome, and controlling energy between those groups is fine to tease out whether the variable actually impacts what we're looking at. It's not relevant to free living individuals necessarily. And we see some interesting things when we look at people in a free living context. So there's a couple of studies, a couple of lines of research that I think are quite interesting in this respect. The first is distribution of energy. We have a lot of really consistent associations now between the timing of food intake relative to your circadian phase and adiposity. There's been a number, now they are cross-sectional studies, but they are quite robust in one sense, which is the circadian sense. So these studies have used measures of what's known as dim light melatonin onset, or DILMO. DILMO is the most robust physiological marker of someone's internal circadian phase. And to measure DILMO, you have to bring people into a lab and take about 13 melatonin samples over the course of, from about, say, 3 to 4 p.m. to about 4 a.m. And that allows you to accurately measure when in that individual melatonin starts to rise. And the onset of melatonin increasing is going to be a marker for when internally things are shifting to the biological night. And so we're going to have decreased glucose tolerance. We're going to have essentially the body preparing itself for the night phase, which is going to be sleep, rest, no food intake. And what these internal processes are essentially giving us a signal for what the body should expect. So it doesn't expect food intake in this period. Now, the importance here is that in every individual, the circadian phase will differ. And in one person, it may be, just argument's sake, 9 o'clock. Someone else, it could be 8, right? So it's going to differ in individuals. What these studies looked at was, having measured DILMO in their participants, looked at the proximity and the distribution of calories relative to DILMO, relative to someone's internal, like, shall we say, biological night. And the closer proximity of food intake to a person's internal biological night was associated with much higher levels of body fat. So in this study, they stratified people by whether they were lean, which was 22% body fat or under, or whether they were obese, which was 32% body fat or over. And people with 32% body fat or over habitually consumed their midpoint of calorie intake, the point at which they consumed 50% of their daily energy, came much closer to their biological night than lean participants. So that's now being observed in 3 studies, all pretty recently. And it stacks up with some of the observational research about eating and adiposity, BMI and adiposity, particularly calorie intake past 8 p.m. seem in observational research is consistently associated with increased BMI. And one of the factors that may influence that is, from a circadian perspective, there seems to be a legacy effect of greater distribution of energy in the morning or in the early part of the day on subsequent appetite and energy intake in free living individuals, such that where people have a lot of energy in the morning or in the early part of the day, by early part of the day, to give it a definition, I mean before, say, 3 p.m., give or take, where people have the bulk of their energy intake in that period, they seem to consume less energy later in the day. The opposite seems to happen with the evening energy kind of intake. When you look at the factors that predispose people to much greater intake later in the day, what tends to emerge is a pattern of skipping energy intake early in the day. But interestingly, once people start initiating eating later in the day, they seem to have much more eating episodes. So their energy intake, when you get to the end of the day and you measure their energy intake and you find this big bulk has come in the evening, what you found is that because inevitably someone is going to go to sleep in that period, you're talking about a lot of energy intake adding up because there's almost like, a time cap on how long someone can eat, whereas someone who's eating earlier in the day, starting eating at 8 o'clock, for example, they may not be going to bed till 10 o'clock that night. So there's a big time course there that they're having most of their energy earlier in the day and that they're kind of somewhat naturally tapering off. Whereas with energy intake past 8 p.m., what we're typically seeing is this kind of like accumulation of eating episodes that get bigger, but also have a shorter duration between them. And that seems to be a factor that then adds up. So people delay initiation of eating, delay initiation of energy intake, of eating, but then are eating with much narrow kind of durations between meals. So they're eating with quite a higher frequency in that period. And they're also eating and distributing more energy to later in the evening. And because that may come then at a time that's more in close proximity to their melatonin onset, to their internal biological night, that seems to be a factor that is going to predispose people to increased adiposity and cardiometabolic health risk, again, over the long term. So in free living individuals, the assumption that a short duration nutrition intervention with calories and protein matched with fat oxidation or weight loss as an outcome translates to everyday life is something that we need to be careful not to over extrapolate.
Yeah, no, and I think that's really important, because I think that is something that has been pervasive in the fitness industry in the last probably decade. Is everyone basically just looks at things through that lens of, well, if you just track on MyFitnessPal, things don't matter anymore because you can just keep it all in order. And that's kind of like a solution sold to everyone, whereas like that's not really how you want to set yourself up for success. And I don't know if this is something that I only started to think about because I don't track calories myself, because when I track calories for years and now I don't anymore. And I haven't for a couple of years. But what I find myself doing is making decisions that are not necessarily based on, all right, how can I reduce calories, but rather how can I engage in behaviors that make it likely that I'm going to eat an appropriate level of calories. So, you know,
Right.
because when
Right.
you see people like who track their calories all the time, one of the things they'll do is just, you know, eat kind of whatever, because it doesn't matter, because they're just like, well, I'll just count it at the end of the day. Whereas when you don't do that, you're like, okay, how can I eat more vegetables, eat more fiber, eat enough
Right.
protein so
Right.
that I don't end up eating more anyway.
Right.
And I think when
Right.
you go through that experience, it does change your perspective a little bit, because you start to think about, all right, when I eat a lot at night, I seem to eat way more then. Like, whether that is purely behavioral, whether it's habitual, whether it's food availability or what, you still notice it and you start to think about it a bit more.
Well, it's a little bit of everything.
Yeah.
And this is one of the big interests that I have. And hopefully I have a study proposal lined up, which I want to look at this kind of question is meal patterning in late chronotypes, people who are self-identify as night owls. And I want to do an analysis where I basically look at the relationship between social jet lag in these late chronotypes, and their pattern, how they distribute energy. And not just, a lot of studies just look at like one day and quantify that as if it's static. What I want to look at is the dynamic change in their meal patterns over the course of like a two week period, just as something preliminary. But the interest in this is there's a kind of coalescence of factors that are biological, psychosocial, and all kind of come together. So the biological factors are, yes, you have differences in chronotype, in someone's preference for time of day, morning or evening, generally, broadly speaking. Most people, I should say, are neutral. But because of things like artificial light exposure at night, 15, 20 years ago, a greater proportion of people at the extremes would have identified as morning types, where actually, this is really interesting, we've seen this shift where more people now identify as like late types or night owls. So that's probably the environmental influence on this. The biological influence is the chronotype aspect, but also your circadian rhythm in the main hunger hormone, ghrelin, peaks around clock time 7 p.m. So it's not an accident that if people undereat in the early part of the day, or for example, with binge eating disorder, people don't binge at 8 a.m. Binge eating disorder is primarily characterized by episodes of overeating. And so there's a biological influence on hunger that is tied to the evening. And what's interesting about this, I've looked at this relative to early distribution of energy. There was a really nice study by a group that do a lot of this research where they compared very high energy breakfast. The majority they consumed, I think it was like 45% of their daily energy at breakfast. And it was also a high protein, high carbohydrate breakfast. So high energy, high protein, high carbohydrate breakfast. Their ghrelin suppression in acutely was massively different and substantially greater to people doing the opposite, consuming a low energy breakfast and a kind of high energy dinner. But this was a weight loss intervention. And the most fascinating thing about this is that they did a 12-week intervention and then, 16-week intervention and then 16-week maintenance or follow-up period where they still kept measuring these factors. And the high energy, high protein breakfast group at 32 weeks, so 16 weeks into maintenance, still had suppressed ghrelin levels. And one thing we typically associate with rebound dieting and rebound weight gain post-diet is elevated ghrelin levels, sustained level of hunger. And this was really interesting because it suggested that beyond the period went into maintenance, they still had suppressed ghrelin levels in response to this temporal distribution of energy. So in the evening, we have this biological predisposition to hunger. Ghrelin peaks in the evening. We have the psychosocial influence of people perhaps being later chronotypes. They had to force themselves with an alarm to get to work. They didn't eat in the early part of the day. They've come home, they're tired, but they're also kind of not tired because they're an evening type anyway. They're tired because they had to get up early. They haven't really eaten a lot during the day. They have this peak in their hunger levels. They are going to be predisposed to overconsumption in that period. And that's exactly what we see in the literature that looks at chronotype and eating behaviors. So late chronotypes are consistently associated with later initiation of food intake, greater distribution of energy later in the day, increased risk for cardiometabolic disease over the long term, and generally higher BMI and higher levels of adiposity than compared to morning types. And so there was a recent study by a Spanish group that do a huge amount of chrono research, where they looked at temporal distribution relative to someone's chronotype. And in morning types who consumed a lot of energy in the early part of the day relative to evening types, it was like an 80% reduction in risk for obesity. And these differences are not insubstantial over the long term. So like you said, absolutely, what we're talking about is in everyday life for most people who aren't tracking calories, can these behavioral factors, could aligning your meal timing and your distribution of energy with your internal circadian biology be a factor that allows you to track calories in a positive sense and maintain a healthy weight or lose weight if that's a goal, and have an overall higher diet quality, because that's another factor that we typically see with the evening chronotypes and the later distribution of energy. People aren't sitting down to eat a lentil salad at 8 o'clock. So there's an association with diet quality as well. I think these factors are hugely relevant for the vast majority of people in the real world that are not plugging everything into MyFitnessPal.
Yeah, and the funny thing about this is that if I was to ask, if I was to ask a personal trainer who's, all evidence-based and stuff about their recommendations for me, let's say in terms of eating late at night, can you still hear me? It was a bit crackly there. If I was to ask a personal trainer that question about, eating late at night and stuff, they might say to me something like, oh, it doesn't really matter. Breakfast isn't that important. If it suits you, just eat more late at night and that's fine. And it's like, okay, cool. Not unreasonable. But if I was to ask my grandmother, she'd probably say, you're not fucking leaving the breakfast table until you finish your porridge and you finish your dinner at 6 p.m. and you won't touch another thing.
Right,
don't even ask. And it's like, damn, Granny, like you're on the ball.
You're on the ball. Yeah. You're on it.
Yeah. So,
but that's okay. So this is a really important point, because I get asked the question a lot about, obviously about breakfast in particular. Part of the problem when we try and this is a problem within the research. I've been writing a review paper, and one of the points that I've been trying to stress is that breakfast, lunch, and dinner as labels are culturally laden labels. They have no inherent meaning whatsoever. And the difficulty with those labels is that what constitutes, for example, breakfast in terms of food choice, meal composition, energy content, timing, completely differs from France to Ireland to Sweden. There's literally this idea that breakfast is something uniform is really problematic from a research perspective. It's also really problematic for translating this into kind of public health policy and nutrition policy and practice. So people think of breakfast in a kind of Irish or English sense. Yeah. People think a meal that is like literally consumed like the moment you roll out of bed, because that's generally what happened when we went to school. That doesn't have to be breakfast. At the same time, a lot of the kind of like meal timing doesn't matter kind of, dismissing, particularly within the fitness industry, really took the whole breakfast thing literally and said, well, breakfast means break fast. That means technically it can come at like 3 p.m. It's just like, well, that's also not great either. It's also not correct, right? So it's a technicality. What we're talking about is an initiation of eating during the day. And so that does not have to be at a specific clock time, for example. So just using myself as an example, like I typically am an early waker, but I'm not hungry till now. So breakfast for me on average is about 9:30 in the morning. It's not, I get up at 6:30. I'm not eating at 7. I'm not eating at 8. I'm just simply not hungry. Yeah. Breakfast for me is 9:30. But this idea then that I think what people get hung up on is that association with the label of breakfast with a certain clock time of day. And it doesn't have to be that. What we're generally talking about with these chrono factors is temporal distribution of energy in an overall sense. So so the French, for example, or there's been a number of really nice analyses that have looked cross-culturally at different patterns. And what you see in some of the Mediterranean countries is you will see that the first meal is not huge in energy content, but the bulk of the daily energy intake comes in a main meal in the middle of the day. Mm-hmm. So the lunchtime basically, and it comes before 3 o'clock. What you see in typical industrialized Western countries that are, let's say, for example, the United States, the UK, Ireland, Australia, and a couple of other countries, is you see a pattern that is the exact opposite, that breakfast is still low in energy intake, lunch is low, but more than breakfast. And there's this linear increase in energy intake over the course of the day, so that the bulk of energy intake is coming in the evening. And in these populations, you're talking often over 40% of daily energy intake is coming in the evening, and so that is completely different to what you see in some of the other kind of population research, where in the US, for example, a really interesting cohort is the Seventh-day Adventists. Now, they have a lot of health behaviors and they abstain from smoking and drinking, and they're quite physically active. But in their culture of eating, they have their 2 biggest meals are breakfast and lunch, and then in their kind of, and I'm not sure how this developed within their kind of religion and cultural beliefs, but they have an extended overnight fast and the bulk of their energy early in the day, and their health outcomes into their 60s and 70s are significantly better than what you see in the general American population, which probably isn't hard as a comparative, but yeah. But as in, that they maintain pretty excellent health into those decades of life. You do see some cultures that have peak energy intake in the kind of early part of the day, breakfast. But in a lot of cultures, you see a tendency of like breakfast being a kind of overall smaller meal, but the bulk of energy coming in a kind of lunchtime meal. What I've noticed in the research overall is that the kind of, if you want to say, cutoff point seems to be around 3 p.m. in the afternoon, give or take. And I'm not saying that's a hard and fast rule. What I'm saying is that tends to be the delineation between when we get into earlier distribution versus later distribution. And as an example of that, the Spanish are a really good population to study chrononutrition in, because they have this cultural tendency for siesta and eating at midnight. But that's not all regions of Spain. And so there's some really interesting cross-cultural comparisons within the Spanish population that you can get. And there was one analysis that looked at the timing of the main meal relative to weight loss. So it was a 20-week weight loss intervention. And then after the intervention, they did a secondary analysis where they looked at weight loss, the amount of weight loss relative to when their main meal came. So this was a population, again, consuming in this typical Mediterranean pattern, about 25% of energy at breakfast, about 50%, the majority of their daily energy in this main meal at lunch, and the other kind of remainder of their energy at dinner. And dinner on average in this was between kind of say 8 o'clock, give or take. But the group who on average consumed their main meal before 3 p.m. lost significantly more weight. They on average were consuming their main meal at about 1:30 in the afternoon, lost significantly more weight over 20 weeks of this intervention than the group consuming it after. The group consuming after were on average eating their main meal at like 4 o'clock. So for that, if you think about that then in the course of the overall day, what that later lunch group were actually doing was consuming 75% of their total daily energy after 3 o'clock, or between 4 and kind of 9 p.m. They were consuming 3/4 of their total daily energy. And so it's that type of temporal distribution that I think is where we're at. It's not, I don't think, about micromanaging the timing of every single meal. I think the broadest way of thinking about this for someone is overall energy load and how you distribute the majority of your energy over the course of the day, and how that might benefit appetite regulation and even have downstream impacts on stuff like sleep and things like that in a positive sense. But I think the important thing to state is that like things like breakfast and lunch, they don't have an inherent meaning in terms of like, breakfast is not 8 a.m. necessarily, it's not 7 a.m., but it's also not 3 p.m. like that. So, you know, I think there's a degree, and this comes back to the idea that the circadian system is both precise and flexible. So there is a degree of flexibility there, but that flexibility can be abused in a sense. And so I think there is a lot of wisdom in what our grannies would have said.
Yep.
And I think, ironically, what the human research in chrononutrition is showing is that there is that benefit, and it's tangible, and it's real in terms of being measurable. And this isn't just in, you know, overweight participants. There's been a few studies that have in otherwise healthy, lean men and women compared the effects of skipping breakfast and fasting until lunchtime versus consuming breakfast on your blood glucose responses to those meals. And people have exaggerated blood glucose responses in the afternoon and evening if energy intake is delayed until later in the afternoon. So these findings are there. I mean, the idea that someone just dismisses them because at the end of the day you can still like lose fat, it doesn't invalidate that these findings are real. The evidence exists.
Yeah, and in terms of that particular point related to breakfast skipping and blood glucose excursions, I believe there is some evidence as well. There's at least one study that basically demonstrated that habituation over time to maybe skipping breakfast, or let's say pushing it back to noon or whatever, that there is a habituation effect in terms of adapting and the glucose excursion not being as bad. But I guess the question there is, you know, if you are engaging in that practice, are you consistent with it, or are you just saying a few days a week I just eat at 1 instead of 8 a.m.
Right. That comes back to the idea that ultimately what food intake, what meal timing is a signal. It's an input to this system. And so yes, there can be habituation, there can be a degree of flexibility in our biological timekeeping. But that flexibility relies on a degree of predictability. The reason it's flexible is because it's capable of adapting to this new schedule, which is why we ultimately get over jet lag, for example. But if we just use the jet lag example as maybe a heuristic that people can grasp, if you flew from Dublin to LA and back once a week, that's you're never going to adapt to either schedule, and your internal physiology is going to be like, what the actual fuck? So that's kind of what we're doing when we're constantly just altering meal patterning. And like I said, I think the I think the proxy of weight loss, fat loss, or these kind of variables as indicative of whether there is a net negative effect of altered meal timing and distribution is just focusing on the wrong metric for the relevance of this particular aspect of nutrition and metabolic health.
Yeah, and one thing I did want to bring up quickly, because it's of relevance to our Muslim friends who are basically engaging in Ramadan, is like basically kind of a two-part question, because obviously I don't expect any practicing Muslim to totally just ditch Ramadan because of just acute health reasons. Like, your values are your values. But what I would say is that, do we have research in this population that is illustrative in this conversation that we've been having? And two, are there better or worse health practices, or have there been any interventions in that population so far?
There's actually been a lot of research in Ramadan, just because it's obviously a fascinating, kind of ecological study to do, where there is this practice that is, going on for however long. It's interesting. There are, it seems, differences in terms of Ramadan is obviously no food or water fast for the period that the sun is up. So I think sometimes people may misconceive that Ramadan means only eating in the evening, but there can be a breakfast in that sense, as long as it's before sunrise. And so you've got research that looks at some of the ways that kind of meal patterning can occur in Ramadan, with, for example, a breaking of the fast before sunrise and then the meal in the evening. Or there is often the predisposition simply to forego all food intake and water intake until the evening then. And there are broad kind of inconsistencies, I think, is probably the best way to characterize. That's how I have kind of characterized the Ramadan research, where the net effect of altered, there's a habituation effect evident in some of the Ramadan research. The negative potential effects on blood lipids and these kind of factors seem to relate to total energy intake, as you might expect, to a degree. But the the associations with factors like, say, adiposity or BMI, like, they're broadly consistent with what you would see in some of the eating behavior research, where people don't eat anything until the evening. And so there is some research that will indicate that people will put on weight over the course of Ramadan, simply because of this change in eating behavior that results in a complete absence of energy intake in the early part of the day or during the actual waking active day period. And then this kind of compensatory energy intake, with the bulk of energy, in fact, all daily energy intake, coming later in the day. So yeah, I think with Ramadan, it's difficult to come to any kind of conclusions that are necessarily independent of what we know from other research as well. It's an interesting case control study, but broadly speaking, the kind of 2 meal a day approach, so to speak, if there is a meal pre-sunrise and a meal afterwards, and as long as there isn't enormous redistribution of energy to that evening meal, that seems to be associated with positive kind of short-term influence on metabolic markers and BMI. So it depends on the structure. This is similar to what you would see with alternate day fasting research as well. you have these approaches where there is a substantial period of the day without food, and the manner in which it then relates to health outcomes comes back down to the distribution factor and how much. So it's distribution of energy, and it's the relationship with total energy and the timing of that, which is why the alternate day fasting research is kind of interesting, but probably not exactly a strategy that people would want to employ over the long term. But yeah, I think I was speaking to someone recently before Ramadan who was getting ready for it, and the conversation was more like trying to focus on like the kind of the 2 meal structure, where it's just the middle of the day, or the daytime period that was like absent food and water intake, but actually having that structure of like 1 meal and then 1 meal at the end of the day, rather than just push everything back to really late in the day.
Good. I think that's good for anyone that's listening, because I think one of the things I was concerned with was that we were going to have this conversation and basically be saying that, eating loads at night probably isn't the best, and then that someone will basically be sitting at home all anxious, being like, oh no, this is going to hurt me so bad, and just from eating at night. Whereas, like as you said, if you're kind of having that 2 meal structure and maybe shifting a little bit more towards earlier in the day, it's probably not going to be detrimental, and maybe could potentially have.
My understanding of Ramadan, again, is that it's based on the timing of the day and light cycle in Mecca. Mm-hmm. So if you're a Muslim in, Ireland, you're not doing Ramadan by the Irish light dark cycle. That's my understanding of it. I could be wrong on that.
Yeah, I'm not going to try and correct you because I'm no expert.
Right. So that my understanding is like, Muslims in different parts of the world will sunrise and sunset will not be according to like the local time, like, because if you were in northern Norway, and that would suck, right? 23-hour fasting a day and then just eating within an hour. But yeah. The Ramadan research is interesting, but you see completely divergent associations depending on the population studied and the distribution of energy. Ultimately, irrespective of cultural practices or otherwise, we come back to this relationship between precision and flexibility. So while there's a degree of flexibility in our ability to adapt to new signals and new feeding rhythms, and timing, there's a limit to that flexibility. And no matter how much you eat at midnight, you're never getting an adaptation to midnight. It's going to have deleterious effects on your response to food intake. So there's, again, I think that's quite important for Ramadan is, there's the timing of energy intake does not necessarily have to be at like 1 a.m. Once sundown is past, there's ways of structuring things.
Yeah, and then I suppose like one of the things I wanted to ask, and that I like to ask when someone's interested in a particular area of research, is has your knowledge of this area changed the way you practice your nutrition? And one of the things that came to mind when I was thinking about this question is, I was out for a few pints with Kieran O'Regan and Danny Lennon in I think September. It was around September. But the thing that I found interesting was like Danny's obviously very interested in the chrononutrition side of things like yourself, and me and Kieran we were going to get pizza from like the pizza by the slice places in Cork, and me and Kieran got pizza, but Danny got none. So I was like, oh, that's his chrononutrition thing, not eating pizza at midnight. How do you bring it into your own life, or do you at all?
Yes, I have, and I've actually completely changed. So pre my interest in all of this, I was very much like a kind of Martin Birkin Lean Gains disciple, where I wouldn't even say I did 16-8. I did more like 18-6. And would routinely fast until 2:30 in the afternoon, have a huge meal at like 9:30 in the evening before bed, my biggest meal of the day coming at that point. But I was tracking everything.
Yeah.
So, hey, it doesn't. And as I kind of learn, I think you go through phases as well. Like, so, there are times in our life where what we value as an outcome for our training and nutrition and all this stuff differs. And there is a point in a man's life where all you're concerned about is being shredded. That's literally, that's it. That's my metric. Like, if I could have massively advanced atherosclerosis, it doesn't matter. I look good, right? So, and that shifts. And I think that shift is natural, and you become more interested in, oh, shit, like I want to be healthy in the long term. I think as well, what can happen is you actually realize you can stay, fit and healthy and still achieve all of those things while actually having a diet that serves you in every other sense. And my focus completely shifted, and I started and now do kind of eat in a completely different way to what I did then, where without doubt my biggest meal of the day is my first meal, which is generally at about 9:30, but like calorie wise, even just size wise, it's always my biggest meal of the day. And I do have an earlier timing of dinner, and I would say that I probably have dinner on average 6:30, clock ticking past 8 o'clock. I don't think I'm I don't think I'm generally reaching for food. And so yeah, I pay attention to this stuff. I do think that they're, over the long term, this is going to, and like you said, I don't track calories anymore. But then again, I don't necessarily need to. The structure of this way of eating, I often have so much energy between my first two meals that I get to dinner and I'm just kind of like, I might just have some like hummus. I don't have that level of hunger in the evening. And so I have changed my eating behavior according to this. And it is something that I think ultimately over time will probably serve me well into aging.
Yeah, no, I like to hear that though, because there's nothing that makes me trust someone less than, for example, like celebrities who are going on about climate change and stuff and they're flying around their private jets. I'm like, I just cannot listen to someone who's not lived by what they actually discuss. So yeah, no, it's actually interesting because like it's something I've done myself as well, because like yourself, going through the whole kind of fit fam stage, like basically what you end up doing is saving up calories for the evening. Like that's what I used to do. That's what a lot of people I know still do, where you basically, because you're tracking calories, you say to yourself, hey, I'm just gonna save all my calories for the evening. That's easy, and I'm gonna just enjoy this big indulgent meal, or not all your calories, but even most. Whereas now, and what I've actually found it, to be honest, like for people listening who only care about body composition, and obviously we have discussed this a bit, but I've definitely found that I find it much easier to regulate my energy intake and actually get better fat loss outcomes when I do have more of my calories at breakfast. So my
I'd agree with that.
Typically be somewhere between like 800 to maybe 1100 calories, high protein, high carbohydrate, and high fat, basically high everything. And it's just leads me to be so full for most of the day. Include, like, obviously I still have lunch, but when it comes to the evening, then it's like, yeah, I want dinner, but I'm not ravenous. And something that I try to get across to people, that I'm sure you've had this conversation with people too, is I've gotten pushback from people when I've tried to maybe have that discussion with them, because they say, oh no, I'm an evening eater, I'm ravenous in the evening. But then the question I always ask is, well, do you think that would be different if you weren't restricting so hard early on in the day? Because that's what people basically do,
Right. I've never had someone come back who, when they've said, look, I'm starving in the evening, and then you look at it and they either don't eat or eat yearly per day. And I'm like, okay, fine. This is a behavioral thing. You're interpreting it as a physiological thing. So what would happen if you change that behavior, and what would that impact be? And I've never had anyone actually come back and say, "Oh, I have loads of energy and across my first 2 meals earlier in the day, and I'm starving in the evening." It hasn't been a level of, particularly if certain dietary characteristics are in place, like if protein intake is high and fiber intake is high, those kind of satiating factors, and then tying those factors to the overall energy load and distribution. I've never really had someone come back and say, "No, man, I'm still absolutely starving in the evening." And I think, to your point, it absolutely is true in the sense that in a phase of my life now where I have zero interest in tracking calories, like ever again, I'm able to maintain a level of leanness that, for someone that's not tracking, I'm perfectly happy with, and it's fairly effortless in doing so, simply because, like you said, there is this kind of like natural regulation in check of energy intake as a result of just thinking about how I distribute my energy, where my energy load over the course of the day comes from. The other thing that I think maybe helps in this as well is, it's, people think about time restricted feeding and they assume that the window has to be really narrow. And I don't actually think that's the case. I think a 10-hour window is probably fine, probably going to benefit over the long term as much as an 8-hour window would. And the distribution within that, if it means that ultimately people aren't necessarily going to bed with a lot of energy that still needs to be processed, at the end of the day, that's the biological reality we can't get away from, is during the night, our physiology is designed for a period of like rest, sleep, fasting, and so some of the associations, and again, they need to be dug out a bit more, but food intake in proximity to bedtime, the duration of an overnight fast, and associated health outcomes is consistent, and it's consistent across populations. So I think there is something in that, and as a population that are probably an example of what not to do, it's the Spanish, this cultural practice of like eating that late into the biological night does not add up to positive health outcomes over 10, 15, 20-year periods. So I think it's really difficult to sustain once we just get beyond the like 10-week fat loss study that matched calories and compared 3 meals versus 6. Once we just park that, because it's not relevant to the discussion we're having, then there's really no way that I could see someone making a case that temporal distribution of energy in humans does not matter. So this matters, whether someone wants to accept that or not, but the research is there, and it's continuing to accumulate in humans. I do acknowledge that this field is very much built on a lot of translational models, but so far, a lot of the emerging research in humans is consistent for what we would expect from human physiology, in terms of when we know from kind of mechanistic research that glucose tolerance and insulin action is enhanced in the early part of the day. There is a physiological basis for the reason why your glycemic control over a 24-hour period is better with higher energy, in the early part of the day and at that first meal. So the mechanistic research stacks up with our understanding of circadian biology, which stacks up with the observational and interventional research looking at temporal distribution of energy. So far, it's a pretty consistent body of evidence, and that makes it worth paying attention to.
100%. I think that's just so important, because obviously, like, no better man to be speaking to, but many like people who get into kind of, cursory reading of research, and kind of even at the university level, sometimes basically worship the randomized control trial, and basically assuming that, there's no way we can take away any information from epidemiology or even mechanistic research sometimes, depending on who you are. Basically, we can take nothing away from those unless we have the RCTs. Whereas when you have this body of evidence where you've got biological plausibility and mechanistic understanding that would make the observational work make sense, and you've got
Yeah.
RCTs basically confirming that, I
Right.
mean, it's hard to just turn around and say we need more RCTs. You know,
It's a ridiculous way of, it's not scientific thinking.
Mhm.
And I would be someone who, I mean, as you know from, you know, conversations we've had, and so I would be someone who's comfortable without RCTs,
Mhm.
coming to conclusions based off a process of inference from things like the Bradford Hill criteria, or, you know, Rothman's causal pi stuff. Like, that way of coming to conclusions for me is true scientific inference. You know, I'm perfectly comfortable without RCTs. I don't need an RCT to tell me, you know, what a reasonable conclusion, an approximate truth of an answer may be from, you know, a coalescence of different lines of observational research coupled with mechanistic or biological plausibility. And often in nutrition science, it's the RCTs that are asking the wrong questions and getting the wrong answers. So I think that, yeah, the veneration of the RCT is definitely a biomedical hangover, but I do understand maybe why university courses very much focus, because otherwise your course is going to be essentially a course in epistemology.
Mhm.
It's just easier to give people the hierarchy of evidence and say they're the best. That's what you look for, right? You circumvent having to go down these kind of like pathways of trying to, you know, teach people scientific inference, which I think would just be a completely different ballgame for any kind of bioscience or biomedical course.
Yeah, and to be fair, like, because from my process of studying medicine so far, like, we have had education in epidemiology, and it has been heavily influenced by, like, maybe it's just happens to be the teachers that we have, but teachers, lecturers, I should say,
Mm.
basically, like, they've put an emphasis on trying to get people to understand causal inference, Rothman's pi, the Bradford Hill criteria, understanding of like how you actually try to make inferences from observational research and stuff
Yeah,
like that. So I don't know, is it the case that, like, am I just lucky that it happens to be in our course, or is this actually always taught in all courses, and then people come out and graduate and start talking about things and just forget that
yeah.
exists? I don't know.
I think what it is I think it's maybe, but I think one, I think, yeah, different universities, you're just lucky, right? You've got some great lecturers, and they're great teachers, and they're good at imparting knowledge, and they get. I think for nutrition, I think the reality for me, and this is just a personal observation, kind of surveying the field, is that the fitness industry has had a disproportionate influence on the conversations in nutrition science, the interpretation of nutrition science, the application of nutrition science by people that are not scientific and haven't had scientific training, and have maybe done like the most rudimentary kind of understanding of what it means to be evidence-based. And I kind of, I don't think that term means anything anymore. And so that has steered a lot of this. So a lot of the kind of the information dissemination specific to nutrition science has been just heavily steered by conversations that don't even have a basic grasp of this kind of stuff. And I think that's probably the problem when it comes to nutrition. Is, you know, we're kind of facing a situation now where I think that there's a lot more focus on these issues, but there's a lot of resistance to it, because for the most part, you've got people whose understanding of nutrition has been developed in a paradigm very much of like, this is it. We look for, you know, we look for the RCTs, hierarchy of evidence, observational research is bullshit. And it's, yeah, it's like what I call the overbrowing of nutrition science. And so I think that's part of the problem as well. You're trying to like drag this kind of like back a little bit against the grain, so to speak.
Yeah, and to kind of answer my own question, I guess I was just thinking back there, like, oh wait, what education did I get in when I studied physiotherapy? And in my physio degree, actually thinking back, it probably was actually more along the lines of what we were saying about worshipping the RCT, and basically that was the way research methods and statistics and stuff was taught and presented. It was kind of all examples of where, in the absence of RCTs, knowledge more or less can't be generated. That's
Right.
the type of impression that I was left with, and I don't
Right.
ever remember being taught about causal inference or anything related to
Yeah.
epistemology or anything. So I suppose
Yeah.
it is interesting to reflect on that, and I think that would have definitely influenced the way that I thought about nutrition as a trainer and someone within the fitness industry, because I've
Mm.
definitely made so many of the mistakes that we've brought up in this podcast. I don't want anyone to think otherwise. Like, I've made those
Yeah.
mistakes. And
Yeah.
it's only kind of looking back now that I can think, okay, now I understand why I would have been the person to say, but you need to standardize everything by energy intake. Just get people to track their calories. It doesn't matter, because at the time, that was my understanding
Right.
of what was needed. And I think,
Yeah.
I guess, for trainers listening to this, the point here is not that, like, trainers cannot be equipped to understand science. Not that at all.
No, not at all. It's
Nor,
just it's
go
go
ahead.
on. No, I was going to say it's just the models that were given. You know, that's what the issue is. It's not the person; it's the models that were given. And what makes, I guess, scientific thinkers is we're willing to expand our mental models based on new information.
Yeah, and another thing I suppose that you say so often is that, look, like, science is hard. You know what I mean?
Yeah,
Trying to understand all this,
science is hard.
stuff is hard.
Yeah, this idea, like we've got all these, like, amateur sleuths online, and it's just like, here's the study, and you're just like, oh. And sometimes it's difficult, and I think that part of, and it's not just, and just, like, to that point, it's not just, the fitness industry necessarily. I just, in the wider conversations, in the social media conversations, and in the kind of, like, wider dissemination, it's obviously just being an influence, because the fitness industry is defined by people who are trying to improve their health, lose weight, lose fat, get shredded, put on muscle, and nutrition is obviously a fundamental component of all of those aims. So it's not an accident that nutrition is so heavily involved in the fitness industry, and it's certainly not an accident that you then had to move from people within the fitness industry to try and be more evidence-based and applying research in practice. So I think that is a natural evolution, but I think that it's also created some kind of, its own barriers to how we progress the conversation when everyone is kind of myopically obsessed with randomized controlled trials and thinks all observational research is worthless and stuff like that. But that issue, even in and of itself, I talk to my friends that have done dietetics, for example, like, that they're given similar mental models,
Mm-hmm.
where, in particular with dietetics, you have the added layer of this kind of glorification of guidelines. Oh, the guidelines say this, so what? are the guidelines accurate? Are they based on good evidence? There isn't that extra layer of questioning. So I always kind of, like, notice that within the dietetic model, it's very, like, emphasis on guidelines and almost like blind faith and trust that they're correct without a more forensic examination of whether they are or not. So these aren't negatives in a sense. They're not positives either. They just are, and we need to understand our various models to be able to, like, better bridge and understand perhaps where someone's coming from. So that's, for me, when I talk to someone in the fitness industry, and maybe I'm hearing that kind of, in my head, I'm able to conceptualize, okay, I can probably understand why they think meal timing is nonsense,
Mm-hmm.
or isn't a thing. I can probably understand the voices that they're listening to. I know who they're getting their information from, and I can understand why they probably think this. And it most likely relates to fat oxidation and energy expenditure and those 3-meal versus 6-meal studies. And in that way, I can then have a productive conversation with them about, well, actually, it's not really that outcome that we're interested in now. It's more like glycemic, and stuff. And so you can be productive rather than being like, this is bullshit. So yeah, how to have more productive conversations, I think, is ultimately where, it's understanding people that are biomedically trained, how they look at evidence, why they might see nutrition science a certain way, understanding how dietetics have their own mental model and how they see the world a certain way, and trying to like build those kind of gaps in and then address those gaps so that we all have a better understanding.
Yeah. And then like 2 points to the credit of personal trainers there is like, one, if you go on to Twitter, follow a few medical doctors who have the little copyright C. Have you seen that in their name? Like
No.
the carnivore doctors, they put the copyright C in their name to indicate that they're carnivores. That's a new thing.
Oh my God.
But like if you go onto Twitter, you follow a few low carb doctors and carnivore doctors and even vegan doctors and stuff.
Right.
You will see that like being well trained in medicine and having gotten education, epidemiology, it does not protect you from making ridiculously unscientific extrapolations from research. So like that, and I get it when personal trainers are like, look, I'm following these doctors, they're supposed to be experts, and they're telling me this. So I can see how easy it is to be led astray. And a second point to the credit of trainers is that a lot of the thought leaders in the fitness industry, what they often do is just put a minus sign against pseudoscience and expect the opposite to be true. So for example, if someone says like intermittent fasting good, they turn around and say intermittent fasting bad, food timing irrelevant. Like that's basically the level
that's such
of
a great
analysis
point
that you're kind of dealing with is like, just take the opposite point and assume that to be true. Like for example, if someone has over extrapolated some of the evidence on saturated fat in the past, for example, they'll turn around and say saturated fat, eat as much as you want, doesn't matter. It doesn't go beyond that. And that's obviously why I've enjoyed some of your conversations digging into, actually, do you know, the consensus actually is probably correct. And then it's like, oh shit, you can't just use your anti-authority bias or your anti-dietetics guide or bias in some cases. So I think as a personal trainer, it's really hard to just navigate that stuff.
It is completely. Yeah. And it's the black and white characterization, like you said, of like, and I had a conversation with Danny actually a while ago, how the consequence of that, if this is a positive, then I'm going with that's actually a minus, right? Mm-hmm. That the consequence of that has been that we've almost got to a point where some of the biggest voices in the nutrition, in the fitness nutrition industry, if you listen to them, you'd basically think nothing fucking matters. Like nothing matters ever. Like macros don't matter, timing doesn't matter, diet doesn't matter. Adherence, like this word adherence is like going to dictate whether you get cardiovascular disease, whether when you're 55. Like, no, like, sorry, bro, adherence is not going to be the factor that dictates whether atherosclerosis develops, So that's my difficulty with that line of thinking, is we've got to a point where apparently absolutely nothing matters for diet and health. And that's not true. This is palpably false. Like,
just calorie fucking deficit, bro.
Just fucking calorie deficit,
that's it,
bro.
That's it. That's full stop.
Yeah,
like
that's it. Full stop.
So without taking too much more of your time, I guess one of the things to quickly just run over is like the quick heuristics and take home points for people. Like, I guess like my summary, and you can add on whatever you wish. It's really simple. Is that, look, if possible, try to shift more of your energy intake towards earlier in the day. It's probably a fairly sound practice.
Yeah.
Don't eat very high amounts of energy too close to bed, and try to be somewhat consistent in the way that you set it up. I suppose like there's some sound heuristics.
Yeah. Try and be consistent enough with timing from a day-to-day basis. That is a late chronotype. For people listening that are kind of like, oh, how do I know? Everyone will have an intuitive sense, but if you Google the Munich Chronotype questionnaire, that's the most validated chronotype questionnaire in research. It will also give you a measure of your social jet lag. For people that are late chronotypes, the thing to pay attention to is social jet lag is, can you modify in any way your life, your work timing, your sleep-wake cycle, to one that's relatively consistent with your free days. And try not to have, for people that are late chronotypes, a really erratic distribution of energy, particularly, distributed later in the day. So I think late chronotypes are the ones that need a little bit more kind of like focus. Morning types are generally fine. So yeah, try and be generally consistent with timing from day to day, whether that's a work day or a free day. Try to avoid a lot of energy intake during the biological night or in the evening, and try to distribute a majority of daily energy earlier in the day, but understanding that breakfast as a meal doesn't have to be, within an hour of waking up. And generally speaking, we're talking about kind of early in the day, perhaps breakfast before midday, and a lunch maybe before 3. And that kind of thing seems to be broadly consistent with what's in the research.
I know. I think that's pretty sound, and I think the great thing about that is that, like, this area of research can seem really complicated if you try to actually dig into it in terms of like the molecular regulation of clocks and all the nutrient signals and hormones, etc. Whereas like the take home points are actually like, yeah, pretty sound. Again, Granny could have told you could have skipped this podcast.
That's it. Yeah, your gran had all the answers.
So to kind of just to quickly finish us off, I've got some informal questions for you. This one I'm interested in, and I think I might know the answer, but I'm not sure. But I wanted to ask you, what was your most transferable lesson as you moved from law to science?
So one of the things, I've thought about this in retrospect, one of the things that in law you're kind of like bet into doing is you never get a case and think, my case is great, like slam dunk. The times that you do that, even when you think you have a strong case, if you just sit back on that, are the times where you generally get your pants pulled down and spanked around the place. So you're kind of conditioned to actually take your own case and pick it apart as much as possible. Probably more so than you look at the other, because you're trying to make it watertight and you're trying to know where your flaws are. And that ties into the second thing, which is you're also conditioned to not just think about evidence, but in law, you have to show where your evidence comes from. And I think that way of thinking, not just, oh, here's evidence, but where does this evidence come from? What's the veracity of the evidence and what's the probity of it? Really, really transferred without me really realizing it at the start. My obsession with nutrition, I started reading observational epidemiology, for example, and then I was suddenly liking, but how can I understand that this is accurate? Are food frequency questions. So I was always digging back into the methodology behind the research to try and understand that more, to be able to show this isn't just evidence because the study found X, but actually the evidence itself can be demonstrated to have merit in terms of its origins. And I think that's been the most important translational characteristic that I brought from law to into science, and I think it's served me really well.
I think that's fascinating. I think it's actually very obvious for anyone that has kind of consumed your content as well, is that there is that extra level of, right, I'm making sure I know how they found this and whether or not their method of even trying to find this was appropriate in the first place, which is a step it's difficult to take, because very often it's easy to read a research paper and skip the methods, and if you do read the methods, assume they're fine. So yeah.
With the last big case I did before I left law, we spent 6 days in the High Court arguing over where a map that was drawn by an engineer in 1976, and the engineer was now dead, came from. Was it based off Ordnance Survey? Was it based off aerial? Like we had to show the provenance of this map that was drawn, and so it wasn't just here's our evidence, here's the map. It was like, well, where does the map come from? So yeah, I've always thought about that as like, that was my parting shot from law. And it's just like, that's my heuristic for looking not just to what the evidence is, but where does it come from itself.
That's mad.
Yeah.
The second quick question was one that I asked David Nolan, and I said I had to ask it to a lawyer. I asked David Nolan, he gave me a hilarious answer. But basically, Immanuel Kant's categorical imperative basically said, act only according to that maxim whereby you can at the same time will that it should become a universal law. So my question at the end of that, asking a lawyer might make me sound really stupid, but if you were to will something that you do or believe into law to make sure that everyone has to do it, what would it be? That might be a silly question, but it's a rough one.
Like,
you can make
as
yourself sound like
a nutrition behavior, or as a general, like anything. I think you can make yourself. What could I make a universal law? No, it's fantastic. I think I would make some degree of national service. When I look at the Nordic model of society, the Central European model of society, where society as a whole is greater than the sum of its parts, and I look at the factors that may underpin that kind of mindset in society, where people are happy to have a more egalitarian society, a less, enormous wealth disparity, inequality, and stuff that you see in kind of neoliberal societies. One consistent one seems to be that people do a year or two of, it doesn't have to be military service, by the way. You could go into the public service, you could go into local government or something like that, but some level of national service, either after we leave school, it could be of huge benefit to creating a society that's kind of like a bit more focused on the society as a whole, rather than just like, how can I like get into banking straight away and make $12 million bonuses. Yeah, I think that might be one of them.
Nice. Good answer.
Yeah,
I think David Nolan's answer was something along the lines of that you wouldn't, like, you can kind of see the reasoning, but that you wouldn't be allowed to have an opinion about anything unless you held like a relevant degree or qualification. I was like, yeah, so like, sounds fantastic on the surface, but you basically just strengthen every conspiracy theory that ever existed.
Right, that ever existed. Yeah. I don't think you could do that to people. Like,
yeah,
I get where he's coming from. I really get where he's coming from.
Yeah, you can see why, but maybe no. Yeah. So the final question,
Yeah.
and I'm actually interested in this from my own interest, but your top 3 books, preferably from different areas, so they could be science, history, English, anything. Add to the reading list.
Wow. My top 3 is, I read voraciously, so
yeah, I know you're a bit of a bibliophile. So
top is vicious. So I'll often end up kind of doubling back onto stuff I've kind of like read recently. Top 3 books. Let me see. Oh my God. So for English, I'll try and think in kind of like different. So for English, I think I'm probably going to go with Mary Shelley's Frankenstein. I think it's absolutely fantastic. I think it has huge relevance for today and the way that we create like an other in society, and the effects of ostracization and all of this kind of stuff. So I think there's so many layers to it. So I'm going to go with Mary Shelley's Frankenstein from the like literature space. Mm-hmm. I think politically, Chomsky's had an enormous impact on me. Would I pick any specific book? Probably not. I'm not sure. I think Global Discontents is incredible. But to be honest, anything by Chomsky. And then historical, I've gone through periods of just being obsessed with the Second World War, so I could default to something there. And yeah, what would I go for history? Actually, although it's a historical novel, for anyone that wants to understand Vietnam better, I think Matterhorn by Karl Merlantes is an incredible, it's basically real life. I mean, he was a Marine so he's really interesting. The author was a Rhodes Scholar that had taken up his scholarship and then for literature, and then went back to the States to join the Marines. And so Matterhorn is very much autobiographical, although it's written as a novel. But in terms of trying to understand Vietnam a bit better, that was, and the race dynamics and the class culture issues and everything that kind of played into it. So yeah.
Legit. I appreciate you've read a lot of books, so that was a hard question to hit you on the spot.
It's really difficult. It's like, fuck.
So Alan, if people are looking to learn more about your work, follow what you're doing, whether it be with Sigma or your own work or anything like that, where would you point people to?
So 3 channels basically. So social media, I only exist on the gram. Really in terms of content. So at @thenutritional_advocate. My own website is alineanutrition.com, ALINEA, and then obviously Sigma Nutrition, which I'm pretty sure all your listeners are familiar with already. And there's with Sigma, there's podcasts that are up there, but then there's also these series of statements on various kind of issues in nutrition that myself and Danny have been working on. So yeah, between the 3 of them, hopefully there's enough there to satisfy anyone that's ready to geek out on science.
Yeah, and I mean, if you are a listener and you're someone who's been maybe intimidated by scientific writing in the past, I would definitely check out the Sigma statements, because I think you've done a great job there in terms of like finding that midpoint between like, this is not a big scientific guideline paper, because man, they're boring to read. But this is also not just some blog. Like, it's like that nice midpoint between here's a consensus, and if someone's interested, they can do more reading. So if you're listening, I would definitely recommend checking those out.
Awesome.
So yeah, thanks very much for coming on, Alan. And
thanks
listeners,
for having me, dude.
Mr. Patrick Farrell will be back in the next episode, and we will see you then.